All right, this video is going to cover section 2.3, which is a review of slope, okay? Concept that we should be pretty familiar with already. We're going to be looking at how to find the slope of a line, including parallel and perpendicular lines, and being able to graph lines that are in slope-intercept form, okay? So recall, slope is a concept specific to linear equations. And the slope of a line, it's just the measure of how the y coordinates are changing in comparison to the x coordinates from point to point. So we're just seeing, are the x values changing at a faster rate as compared to the y's, or vice versa? Okay. Let's give you a quick little illustration here. All right, so here you see I have a line graphed, and it's defined by 2 points. And as I move this slider along, you're going to see two numbers show up. One number is going to represent the vertical change from one point to the other. This vertical change is often referred to as the rise. And then the second number you'll see is for the horizontal change from point to point. This number is often referred to as the run. Okay, so it's going to start off by showing the rise. So we're going to move a total of 5 units vertically to go from this bottom point to the higher point. And then we're going to run 8 units in the horizontal direction. Okay, and then notice it's creating the slope of 5/8. So we put the rise up top and the run on the bottom in that fraction. Slope is 5/8. Notice there's a triangle created here. This is often referred to as the slope triangle. And it wouldn't matter if you picked these 2 points or any other points on this particular line. The slope will always equate to a value of 5/8. Okay. Now there are 4 different types of slope for any given line. Okay. So lines that behave in this fashion, where they have what I'll refer to as an upward trend from left to right, these lines will have a positive slope. Okay. If your line behaves in this fashion with a downward trend from left to right, then you'll have a negative slope. And then you could have a horizontal line. Horizontal lines always have a slope of 0 because there is no vertical change from point to point. And then lastly, you could have a vertical line. It's understood that the slope of a vertical line is undefined. Okay. All right. Now let's come up with a formula that we can use to find the slope of a line given 2 points on that line. All right. Here I have a picture of my line defined by 2 points that are in blue, and I'm going to label these 2 points as, I'll do this lower one. This is x1, y1, and then this is x2, y2. Okay. And slope is often represented with the letter M. Okay. And we saw in that illustration that the slope is always a measurement of the rise over the run. So rise is the vertical change, run is the horizontal change, right? So in my picture, the vertical change is right here, the rise, and then here's your run. I can find the rise by taking the coordinate of y sub 2 and just subtracting it by y sub 1. That'll give me that vertical change right there. And then I can find the run very similarly, x sub 2 minus x sub 1. Okay, so hopefully that formula looks familiar to you and you've seen it in the past. Now let's use it to find the slope of the line that passes through -3, 2 and 5, 6. Okay, I'm going to designate The first point is x1, y1. The second point is x2, y2. All right. Doesn't matter which one you designate as which set of coordinates there. Should work out the same either way. So slope of this line, I'll take y sub 2, subtract it by y sub 1 over x sub 2 minus x sub 1. Of course, we know that's going to turn to addition. I'll end up with 4 over 8. And that reduces, right, to 1/2. Okay. All right, so basically what that is saying is that from one point to the next on this line, you can expect for every 1 unit of vertical change, there's going to be 2 units of horizontal change from one point to the next. Okay. All right, now moving forward. So lines have equations that represent their set of ordered pairs, right? So one form for a linear equation is slope-intercept form, and it's often written as y equals mx plus b. And the reason this is called slope-intercept form is because within the equation, you have the slope of the line shown to you, and then you also have the y-intercept of the line shown to you. Makes it really easy to graph the line instead of like plugging values in for x and getting values out for y and plotting each of those points. You simply could just identify the y-intercept when it's in this form, plot that point, and then use the slope to find more points. Okay, so let's take each of the equations that are below here, and we're going to rewrite them in slope-intercept form, and then once we're there, we'll graph them. Okay. In order to put in slope-intercept form, you simply have to solve the equation for y. So over here on the left, I'll begin by subtracting 6 over. I'll then subtract 2x over. I'll divide both sides by -5. And that'll take me to y equals 2/5 x plus 2. Okay. So the first thing you're going to do to graph this is you're going to focus on this 2 at the end there. That's your y-intercept, which is where your line's crossing the y-axis. So you're going to put a point at 2 on the y-axis. Now you'll focus on the slope of 2/5. So from this initial point we plotted, we're going to rise up 2. So we're going to go up 2 units and run 5 units to the right, which is the positive direction. Place this right there. Or from that initial point, you could have gone down 2 units. Down is the negative direction, and then 5 to the left. Left is also negative, but if you think negative over negative gives you a positive as well. All right, and then we just connect those points with our line. Okay, next example, very similar process. I'm going to subtract 3 over to the other side. Then I'm going to subtract 1/2 x over. Divide by -2. And in slope-intercept form, y is going to equal 1/4 x plus 5/2, or plus 2.5. Okay. So now that I'm in slope-intercept form, I identify the y-intercept as 5/2. And then I identify the slope as 1/4. So from that initial point, rise up 1, run 4 to the right. Or you could go down 1 4 to the left. There you have it. All right, moving forward. Now let's just discuss some of the relationships between the slopes of parallel and perpendicular lines, okay? Let me click this illustration here. All right, here you can see we have lines M and N. Visually, they sure appear to be parallel to one another, right? Like they're not intersecting each other. Notice on line M, you have the slope triangle already associated with it. And you can see that if I drag that yellow point over here, the same slope triangle applies to line N. So that means this is depicting that lines M and N have the same slope, okay? So parallel lines have equal slopes, all right? What about perpendicular lines? Lines that intersect to form a right angle. All right, so here we have lines G and F. They are perpendicular. Notice they are intersecting to form a right angle there. And you have the slope triangles for each of these lines. Line G slope right now is -5/2, and line F's slope is 2/5. Okay, now I can play around with points A and B here that are defining line F, and as I adjust those, it's going to adjust line G as well to keep the two lines perpendicular to each other. So we want to make some observations about the slopes as they change. Okay, so let's say I move point B up one space. Now the slope of line F is 3/5, and the slope of line G changes to -5/3. Okay, what if I moved there? Slopes are 3/4, -4/3. How about here? Slopes are -5 and +1/5. Are you noticing anything special here? Any relationship? I hope you are. It's that the slopes of perpendicular lines are opposite reciprocals. Okay, so let's drive that home further. Let's say one of our lines has a slope of -2/5. Then the perpendicular line would have to have a slope of +5/2. So I changed the sign and I switched the numerator and the denominator. Okay? All right, now it's your turn. You're gonna go to practice one. As always, pause the video, work through the problem yourself, and then come back and check your work with mine.